This is the part 5 of a tutorial where you are designing and building this keyboard. In this video, we are going to improve PCB layout. We are going to make our PCB better. If you haven't watched the previous parts of this tutorial, links are in the description. Let's start. We are going to improve layout around this USB connector, copper region, polygon, and we are going to draw copper area. So this area is going to be filled up with copper. We would like to connect it to +5 USB. And we would like to change the way how the paths are connected. See, it's defined based on these rules. So go to design rule, and here copper region, I'm going to change this to direct and this one to direct. Okay, now select it, and we need to rebuild this copper. See what happened? The paths are now directly connected to the copper. We will do same also here. So I'm going to draw polygon around all these pins. Do it like this. Okay. Use left click to confirm the corner, or you can use backspace if you make a mistake. Okay. Confirm. Perfect. You can adjust the shape, just hold the left button down and move the edges. And if you adjust the copper or the polygon, then you need to always rebuild the polygon. We are going to improve the USB also on the top layer. So first put more vias here. For powers, you would like to use sometimes more vias, because one via can only carry limited amount of current. I'm going to adjust this a little bit. Okay, place more vias also here. It doesn't mean because there will be not like super high currents flowing through these polygons, but you know, it's good to have this kind of habits that when you are drawing specific signals or specific tracks, you use them always. For example, use binder tracks for powers and use more vias for powers. I'm going to draw big polygon on top layer, maybe like this. Go around the track and around the vias. Okay, okay. Be sure it's connected correctly. So I'm going to pick this +5 USB. And it looks okay, it looks good. Go back on bottom layer. And we are going to continue down here. This time I'm going to use simple rectangle. Maybe like this. Okay. I'm going to place more vias. Okay, maybe let's do it like this. Okay, one more. Maybe I would like to change this a little bit. Okay, so it looks nicer. There we need a lot of space. That's why I'm thinking a lot how to move it, but it's okay. And continue on top layer. Maybe like this. Confirm. Okay. Next, this ground. So again, we need more vias. I placed vias on the path because then they automatically pick up the net of the path. And we need more vias here. And don't forget, this is a voltage regulator, a linear voltage regulator, so it may get warm or hot. So what I'm going to do, I'm going to place many vias here because we have like two big ground planes inside of the PCB. They can help to spread the heat. And also we will make a little bit bigger copper pour here on the bottom side around the regulator. I'm just trying to place these vias nicely. So it looks nice. Okay. And a few more. And the last one. Now we are going to draw polygon around all these vias and ground paths. Draw it maybe like this. If needed, you can adjust the shape later after you finish drawing the polygon. So it doesn't have to be right the first time. It's connected to ground, okay. I'm just double checking. Save. Now here we would like to improve these 3.3 volts. So first I'm going to put here more vias. Do it maybe like this. Okay. Okay. I'm going to delete this. and we can draw polygon. So do it maybe like this. Okay. And delete. Connect everything. We need to do it also here on the other side. Connect all the vias together. Be sure it's connected to correct net. Oops. Okay. Press Shift S, you can change the views to see where you still have space. Now let's improve this one. Maybe we would like to move this a little bit. Okay. Double check on bottom. Okay. Okay. Here. Maybe move it. I'm going to redraw this. Okay, perfect. This looks good. And now 3.3 volts. This is going to be big polygon, so we can start drawing it somewhere here. And just go around and connect all the 3.3 volt areas together. I'm just thinking how to draw it. You can do it exactly the same way as I do it. Okay. And be sure you use the correct net. Double check everything. I don't like this here. Okay, this looks better. Maybe move this a little bit so it looks nicer. I just redraw it because I wanted to go away from the board edge like this. What next? I still don't like this. I'm going to put this back. This is actually, this is really like visual thing. Because this is a top layer, everyone will see this top layer. So I try to make it as nice as possible. These small changes, what I'm doing right now, they are not really going to influence anything electrical on the board. But still keep all the tracks away from each other. Okay, like here I'm going to move it a little bit because of crosstalk. Okay, if we have a lot of space, so we don't need to route them very close to each other. If you go to my YouTube channel, you can simply just search for crosstalk and you will find many videos on this topic. It will help you understand why we are moving tracks away from each other. Watch these videos, okay? Just double checking. Okay. Looks good. Now the bottom. Again, just playing around, not really something what would influence quality of the signals. It's just making them nicer because these tracks are on bottom layer, and again, everyone who is holding your PCB will see them. Okay. Looks good. Shift S. Save. Go to my YouTube channel and search for VIA and watch these videos. Okay, they will help you to understand what we are going to do next. We are going to place something what is called stitching vias. So to these places where our tracks are going from top to bottom or from bottom to top layer, we are going to place ground vias. These are called stitching vias, and in our case we are using ground vias because they will connect the ground plane on layer 2 with the ground plane on layer 3. Okay, and this will help to keep quality of the signals on our PCB. Place these stitching vias close to these places where our tracks are changing layers. We would like to place it also here, down. These are just ground vias. and we need to place them also to all the other places. For example, here you can see tracks are changing layers, so I'm going to place some stitching or ground vias also here, and I would like to say, of course, your board would work even without these stitching vias, but this is very similar to what I was talking about when we were improving powers and when we use multiple vias for powers. So this is just make this as a habit, because these stitching vias are very important for example, for high speed. They will help you to keep EMC and EMI. They will help you to improve EMC and EMI, and for more complicated boards, they are very, very important. So even when we are designing this very simple board, it's good to create this habit and use this habit even on simple boards. And especially we have a lot of free space here, so there are already some vias, so we can place these extra vias on our PCB. We can place one here. In case there are already some vias, because there are, I don't know, decoupling capacitors or something, you don't need to place them there, okay? And these, very simply to say, these vias are helping to control the path of return currents for the signals which are traveling through the tracks. I'm trying to double check all the places where we can easily place these vias, and also when we need them or where we need them. Not much space here, but there are many ground vias already anyway. Maybe here. And here. Okay. What with this? Not much space here. We may need to move it. Okay. Okay. Maybe here. Go through your PCB. If your layout is a little bit different, or if you are designing your own keyboard with different shape or different number of keys, go through your PCB layout, find these kind of places and put there these stitching vias or ground vias. Okay. Here. Move this little bit. And we can place also one here. There is no space to place it very close to the via, but at least place some of them around. Okay, this looks good. Did I miss something? Maybe down here. And maybe here. Okay. Ideally, you would like to have like one stitching via per one signal, but yeah, it's not always possible. Save. Go to nets, and we are going to double check the nets. We are going to start with the important one, USB. So we can't really do much about this one. We already mentioned this, so it's kind of okay. Now it continues down here. Okay. Very important signal, so be sure you check it properly. It looks good. There is nothing routed very close to these important signals, and they look good. Now clock. Clock signal is very important. We would like to see what is routed close to the clock. I will move it a little bit away from the other signals. Okay. What else? Reset is important signal. So double check how it is routed. Maybe I'm going to move this away from reset, so it doesn't pick up any noise from the neighbor signals. Not much space here. But otherwise looks good. This is also clock. Lot of space around this track, so that's good. USB and crystal. These are all very important tracks. Double check how they are routed, what is close to these tracks. Okay. Now go on these inner layers and double check how these ground planes are connected to ground pins. Like this. This is called thermal relief, and we would like to make it maybe a little bit wider. So go into these design rules and change this width to be 15. We use this thermal relief so it is easier to solder the pins. I'm just double checking. You need to rebuild these planes, okay? Don't forget. Watch what's going to happen. It's a little bit wider. So this thermal relief helps with soldering, especially through hole pins soldering. Save. Now we are going to work with components, and we would like to show the reference designators for these encoders and switches. So they are on top silkscreen layer. This is the layer which is usually white, and we would like to double check the size. In JLC PCB manufacturing capabilities, we would like to know how small, or what is the smallest text what they can do. 6 mil, 40 mils. So I'm going to double check 645. Okay, they can manufacture this. I'm going to change the grid, and I'm going to move these component designators so it looks nicer. We are only going to show these component designators for these key components. We don't need to show it for every single component on our PCB. Make it nicer. Okay. I'm just double checking the position, X and Y position, because I would like to see them, I would like to have them in the same column and in the same row. Okay, perfect. Now, maybe we would like to add some text here. So place text, RGB. Okay, maybe that's too big. Be sure it's on top silkscreen layer, and again, don't forget the minimum values what we can use. We would like to make it smaller, so 6 and 60. Maybe center. Okay, I think this looks good. We can copy it and paste. We need more. So this one is going to be RGB user LED. Maybe move it down like this. So it's all in one row. This one is user, and this one is power. Always place this kind of information on PCB so people can immediately recognize. I'm just double checking. Okay, this is the power LED. People can immediately recognize what are these LEDs for, even without reading manual. It's very helpful. Save. Now we can do same on bottom layer and use this flipboard feature, which is basically used very often for text, because when you flip the board, you will see the bottom layer from the same view as if you would be holding the board in your hand, so you can read the text. You are not looking at the bottom layer through the top layer, but you are really looking on the bottom layer when you flip the board. Very useful when you are creating text. So same reason as why we place the text for the LEDs, we are going to also place some text to these buttons. So without reading manual, you will know, or everyone will know, what are these buttons for. So this one is the boot button. Place the text the same direction. It's very helpful because then it's easier to read. This one is reset. I'm just going to double check. Yeah, that's the reset button. Maybe move it a little bit. And looks good. Maybe double check in 3D view. Okay, maybe I will move it a little bit like this and this. Next, I'm going to copy this and paste. We would like to add some useful information. For example, board name and version. Very important. And copyright. Here you can put your name or your company name. You created this board. Don't forget, okay, board version is very important. Sometimes you may have multiple board versions on your table. You would like to know which one is the most recent one. Looks good. There are some vias going over the text, or the text is going over the vias, but it will be fine. I'm going to copy this and I'm going to paste it here into this empty space. And I'm going to put here a little bit of advertisement. You know, I spend a lot of time. Actually, I really thought this tutorial, in total, it will have like 4 hours. It's much more work than what I was expecting. So I'm going to put here a little bit of advertisement to our courses, because that's actually how I make money, and that's what helps me to make these free YouTube tutorials. Without these online courses, I would not be able to do these free YouTube tutorials. So thank you very much to everyone who signed up for our courses. And I'm going to include also the website. You already know our website, do you? fedevel.com. Of course, you can put here something about what you do. or any kind of information what you would like to put here. It's a nice empty space, so you can use it. I love it. Very nice. Okay. And now something special. We would like to place a logo on our board. I'm going to show you how you can place logo. So this is the picture what we are going to place on our board. You prepare the picture in black and white, and I'm going to use special technique. We would like to have the logo gold. So what I'm going to do, I'm going to create copper area here in this place. And instead of placing the logo on seal screen layer, we will place it on this mask layer. So we will unmask the area where the logo is. And when we do the gold finishing, here be sure you use correct size and then click here, very important. So it will adjust also the other size. And when we do it this way, the logo will be gold, okay? Because when we use the gold finish on our PCB, all the unmasked areas will be gold, and that's what we can see here, okay? The logo is the unmasked area, and it will be gold. Very cool trick. And it's very easy. What we are going to do now, we are going to rebuild the ground planes inside of our PCB, and we are going to rerun design rule check. You remember we still had some errors, these clearance errors in our PCB, and we would like to fix them. Double check what these are about. So they are about the distance between these holes and slots and paths. And double check what is the minimum distance we need to use. So what I'm going to do, I'm going to simply just change the rule because we can't really do much about this. It has to be manufactured this way. So if we don't want to see these errors, we just need to adjust the rule. Okay, and it fixed all the errors. Perfect. We have no errors. That's really good. And next, I'm going to add license. So I'm going to search for this, and it will help me to create the license for this project. If you are building your own board, your own open source project, maybe you can find this useful. This can give you an idea how you can add license on your own projects. So I'm just going through these steps, and okay, I will fill out something. Okay, done. Now you can see recommended license. Credit must be given, okay. Only non-commercial, okay. And adaptations need to share the same terms. That's exactly what I would like to use. This is how the link looks. Okay, I can copy this, and I'm going to place it inside of my board on this document layer. Sometimes I don't place license into my tutorials, but many people they don't even mention these projects, and I spend a lot of time on creating them. It's always sad to see your own board with someone else's logo placed on top of it. So I would like to make it clear that if someone really would like to use this project, it's fine, but not for commercial use, and don't forget to mention my original project. Okay, I'm sure everyone understands why I'm doing this. Now, something very important. Do you remember this recommended digital track impedance 50 ohms? It means for all the digital tracks on our PCB, we would like to use this track width 6.1 mil. Okay, when I zoom in and when we select this, you can see it is 8 mils right now. We will use this find filter for all the tracks with same width, 8 mil. We would like to select all these 8 mil tracks. These are all the digital tracks on our board. I'm just double checking. This is exactly the reason why we used 8.1 for the power tracks and not 8. And I'm going to change the line width to 6. Okay, I'm not going to use 6.1 because the USB has 6.1. I don't want to mix it. And now all of them are 6 mils. Okay, so for 50 ohm impedance, 6 mils, all our digital tracks on our board are now routed by 50 ohms. Okay, I'm just double checking if it's possible to manufacture it. So multi-layer minimum track 3.5, they can manufacture 6 mils, no problem. We need to also update the minimum track width, so we are not getting the errors or DRC errors. Confirm and just double check. Rerun DRC, no errors. Okay, perfect. Save. And we are going to double check the nets. So this is power net. Go through every single net on your board and double check if everything is connected correctly. Especially see these very thin tracks on power nets. We would like to be sure they are not 6 mils. So that's what I'm double checking. These are all 8.1, that's good. Oh, this one, see? This one is thinner. I'm going to double check, maybe I made a mistake. Oh yeah, it's 6 mil, so this one is 8.1, this one is 6. So I'm going to change this to 8.1. This is the reason why you would like to go through every single net on your board, just to be sure, for example, we didn't change the track width by mistake. Okay. Watch how these are routed. So these are connecting the 5.1K. These are the other nets. Okay, not very important nets. Looks good. Everything looks good. I always do this for every single board what I design. Spend time double checking this. It's not so time consuming and you can find some mistakes. Looks good. Do it also for your own board. It's not very difficult to check these. Everything looks okay. and the ground. Again, don't forget to double check the width of these tracks. There are many ground connections. Okay, buffer. Now these LEDs. Flash. We already checked the reset. Okay, everything looks good. We already checked this. But this is the final check. Okay, this is the check just before basically our board is completely finished. I'm going to double check the width again. I would like to be sure all of these tracks have 6 mils. Okay, perfect. I'm going to lock the top side and bottom side of our PCB so we don't make there any changes by mistake. And your board is finished. Have a look. This is your board. Wow. Now you are ready to generate the files for manufacturing. But before we generate the files, we are going to design enclosure or the case, the box for our keyboard. So let's continue. The link to the next part is in the description. And don't forget, if you would like to learn more about electronics, check out our online courses about schematic design, PCB layout, EMC, measurement. We have courses about KeyCAD, Altium Designer and more. Go to fedevel.com and have a look. Thank you very much and see you in the next video. Bye!